Hi everybody, we're looking at chapter 17, section 2 this time. We're going to be talking about measuring and expressing enthalpy. We had enthalpy as a previous vocabulary word. Remember, the enthalpy is simply another way of basically saying heat. I don't know why they decided to use so many different words, but enthalpy simply means heat. We're going to go on and look at some more definitions. First we have calorimetry. Calorimetry is basically, it's a way of measuring the heat flow that goes into or out of a system, and we've already discussed the concept that's right here in class yesterday, that the heat released by the system is equal to the heat that's absorbed by the surroundings. So in other words, we talked about if I'm holding a coffee cup and my coffee is losing 30 joules of heat, then something somewhere has to be gaining 30 joules of heat, either my hand, the countertop, the air, all of those things, but what's gained has to be equally lost. And then a calorimeter is simply a device that you use to do this with. And I'm going to show you a couple of examples of those. Right here on the left, looking over at this one, we have what's called a bomb calorimeter. It's called a bomb calorimeter because basically you set the stuff that's inside of it on fire. So if you follow my little pointer here, right here's like the little place where we're burning something. Maybe this is like a bowl of Cheerios. We want to figure out how many calories or how many joules are in some Cheerios. And so we put the sample in the little cup down here. And then what they do is they actually will ignite it in some way, shape, or form, and it's in a little waterproof chamber. And then the little chamber is submerged in the water that you see around it. And there's a thermometer that's in the water, and there's a little stir to mix it all up so that the water gets to be an average temperature. And as you burn the Cheerios, you see how much the water heats up. A more simple way to do this is over here. This is called a coffee cup calorimeter, and as you can see, it's basically just two insulated, like two styrofoam cups that are put inside of each other. Traps a little bit of air in between the two cups, which insulates a little bit. And you can do the same exact thing in there, except you can't burn food. But you could drop like a piece of metal in there and see how much the water changes temperature, or you could do a chemical reaction in there and see how much the water changes temperature. A little bit more about calorimetry. We have enthalpy right here. Again, enthalpy is H. It's the heat content of a system. If you put delta H, remember that the little triangle means change in. It's the change in enthalpy. You can use these two interchangeably. U or delta H, it's the same difference. It's just kind of confusing. Your reference table uses both, so we are going to use both in class. And then we also have the concept that we've already been talking about, that basically the heat of the surroundings is equal to the negative Q of the system, the negative heat of the system. It's kind of the simplified way of saying it is that the heat that's lost has to be equal to the heat that's gained. So if you wanted to put basically Q lost equals negative Q gained, or Q gained equals negative Q lost, you could say that as well. One of them has to be negative, though, in order to make this work, and you'll see that more so with problems in class as we calculate it. And it says, for many problems, the enthalpy of the system is being asked for, but it's going to be something that you can't stick a thermometer into, and so we're going to have to do it by looking at the surroundings. And we're going to do a lot of this in class. This gets easier to understand as you actually see the problems with it. Then we have thermochemical equations. Thermo means heat, and chemical, of course, is referring to the chemical part of things, like chemicals. So it's a chemical equation. We've looked at those. Like here's several of them down here. Here's one equation. Here's another equation. But what we do is we add heat to those equations. So as you see right here, I have this equation, CaO plus H2O yields CaOH2. We've added enthalpy over here to the right. And it's called heat of reaction. So right here, negative 65.2 kilojoules is the heat of reaction for this equation that it's written with. And so what you can do is you can rewrite the equation like down here below, and you can actually put the kilojoules in it as one of the products or the reactants. How you decide whether to put it as a product on the right of the arrow or as a reactant like this one over on the left of the arrow depends upon the sign that's with it. You see, this one's negative, and it's negative because the heat is being lost. It's being put out or given off, and that makes it exothermic. Remember, exo means to go out, and therm is heat, so heat is going out. And the way that you show that it's coming out is you write it on the right-hand side. The reason that this one here is written on the left of the arrow is because it's endothermic. It's a positive number. And remember, endo means in, so heat is going in. And the way that it's going in is by putting it in the reactants. We have one last thing here. And it says the amount of heat released or absorbed depends upon the number of moles of the reactants that are involved. I hate to tell you this, but we're going to do some mole problems using this. We'll do those in class, so no fears about that appearing here. So we'll look at all of these good little things right here, that if the number of moles increases by 2, then you would just simply double it. And then another thing we could do with it is the heat of combustion. And if you think about it, combustion means burning. So the heat of combustion is simply how much heat would be released when something is burned. And we could do some calculations with that as well. So I look forward to talking about this more with you in class.